Here we go. You're back with Mr. Naughton, and you're like, please, God, no. But it is me. I'm back. And we are going to do some more finding zeros of polynomials. 2.5, continue. Take it over from the lovely and talented Mrs. Rooker. Give her a round of applause. She did a wonderful job on Descartes' rule of signs and all that jazz. So, ladies and gentlemen, boys and girls, before we just jump into this, I want to give you guys just a little bit of a to-do list. So the first thing I want you to do is I want you to find your degree. Because degree is going to be helpful because that's going to tell us the max number of answers we are going to have. It's called the fundamental rule of algebra. There's a couple of different parts to the rule, but the important part is that, hey, it's going to tell you how many answers you should have when you're all said and done. It takes into account multiplicity, so and double roots and triple roots like we've been talking about throughout this review unit, but that's the first thing. The second thing we're going to want to do is we're going to want to do synthetic division. It's much easier than longer division, but that's going to be the way it goes. Now, you want to do synthetic division until you get to an x squared. And that's when you're going to go ahead and do a factor, or you're going to have to do the quadratic formula. Okay? So be on the lookout. If you want to use Descartes' rules of signs, it's a wonderful tool to help give you an idea of how many zeros you're going to have. We'll go ahead and do Descartes' rule of signs for the first couple, and then I think we're going to go ahead and call it good. Alrighty? So the other part that I just want to mention before we get started is you want to pay attention in the video, get the basics. When you get to class and you talk with your good old teacher, we get me, Leisman, G-Money, Rooker, they're going to show you some cool ways with a calculator to make this a little bit easier. But even when you use the calculator, get your list of zeros, you are definitely still going to have to show your work. So this is still going to apply. Alrighty. So when we do our synthetic division, again, I look at the degree, which is a 4. Okay. So I'm going to have 4 zeros when I'm all said and done. The other reason why I want to look at the degree is then I want to see if there's any what G would call skippers. We're missing zeros. So it should go 4 all the way to 0. So it goes 4, 3, 2, 1, no X. So I don't have to put any placeholders in there, which is important because on example 3, we're going to need those. Cool? So I know I have 4 possible zeros. All right, let's do our Descartes' rule of signs because I said I would do it for the first one. So I'm going to go DRS, positive sides, and then negative sides. So this is a positive, so positive to negative, so that's one change. So negative to negative, no change, negative to negative, no change, and then negative to positive, so that's another one. So I'm going to have the possibility of 2 or 0, because remember, they come in pairs, okay? So, or they could be singles, I get that wrong, but you always go down by 2, that's what I meant to say. All right, let's do the other sign check. So with my negatives, whenever you put in the negatives, these even ones, they're not going to change, as well as this 8, because they're not going to change. Because if you square something or fourth it, it's always a negative times a negative, which is a positive. So those are going to stay put. It's these ones right here that are going to be a sign change. Okay, so I'm going to rewrite this as 3x to the 4th plus 11x cubed minus 3x squared, no change, plus a 6x, there's a change, plus 8. Let's take a gander. So, again, this is a positive, so positive to positive, no change. There's 1. Then negative to positive, there's 2. And then none there. So I have 2 there. So if I erase this, you can rewrite it if you need to see. So, ladies and gentlemen, that's saying I have 2 or 0 positives, 2 or 0 negatives, and of course we do have imaginary. Okay, so in this case, ladies and gentlemen, if I have 2 of each, that's going to be 0, or I could have 2 or even possibly 4 if they're both 0. So that's why the Descartes rule of signs is saying these are our scenarios. I'm not going to have an odd number of zeros that are negative, imaginary, or positive. So we have that. So the next thing we have to do is our synthetic division, which means we need our list of zeros. So I'm going to go ahead and mosey on over here and make my list. So I call them the P over Q's. The Q is from that 8, and the P is the leading coefficient. So my 8, the factors are going to be 1, 2, 4, and 8. And then the 3 is going to be 1 and 3. So obviously I'm going to have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then I'm going to have plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3. Cool with that? Alrighty. So remember, the idea is when we do our synthetic division, or as some of us just call the L, this needs to be a 0. Your last remainder term needs to be a 0 if it goes in evenly. So, spoiler alert, if you put in 1, 2, or 8, you're not going to get 0. It takes 2, 4. And how do you do that? Just a little guess and check. But we're going to go straight to the answers to make this video a little bit shorter. Again, it's just guess and check. Alrighty, so remember we always drop the first one, so that's a 3. And then I do 4 times 3, which is going to give me 12. That's going to be 1. 4 times 1 is going to give me 4. That's a 1. 4 times 1 is going to give me 4. That's a -2. And then that's an 8. And so we're going to get our remainder of 0. Yay, it worked! Alrighty. Now, as we have when we do our division, you're going to have a degree 1 less. So this was an x to the 4th, so that means this is going to be a 3x cubed plus x squared plus x minus 2. You're not at x squared yet, which means we need to continue to do a synthetic division. So the next one that's going to work on our little synthetic division train is going to be 2/3. So we'll do 3, 1, 1, -2. All right, we always drop the first one down. So that's 3. 2/3 times 3. Hopefully you guys are good at this, but if you need, use a calculator. That's 2. Add those, you're going to get 3. That's going to give me a 2. This is a 3. This is a 2. That's a 0. Okay? Boom shakalaka. So we have 3x squared plus 3x plus 3. Now that's kind of funky. Wait a minute, let's look at that. Why on God's green earth are they all divisible by 3? Well, that's because this right here is one of your zeros. We divided it out by 3 already. So really, we would have x minus 4, which comes from this answer right here, and then x minus 2/3, which comes from this one right here. So if I were to write that in its factored form, oops, it would look something like this, because then this part would be the caboose. No one wants to see a 2/3 in the middle of our list of zeros. So what we're going to do is we're going to factor out a 3, and then I'm going to apply it to this 0 right there to get rid of your fraction. So I'm going to get x minus 4, and then the 3x minus 2, and then the x squared plus 1x plus 1, which is what happens when we get and we take out a 3. Cool? Now, that was just to kind of explain how we're going to go ahead and we get all these 3's and these steps. But again, our answer is going to be this 2/3 and that 4, and then whatever this quadratic formula is going to come up with. And the reason we're going to do quadratic formula is this doesn't factor. So sad. So negative b plus or minus b squared minus 4ac all over 2a. Do I have to have this memorized, Mr. N? Absolutely you do. At this point, you are trig students, absolutely. So negative 1 plus or minus 1 squared minus 4 times 1 times 1 all over 2 times 1. And then we're going to go ahead and do some math magic. You always want to do what's inside the root first. So negative 1 plus or minus, that's going to be 1 minus 4 divided by 2. And so that's negative 1 plus or minus negative 3 over 2. And because I have a negative in my root, that's imaginary. So that's going to go ahead and give us negative 1 plus or minus I root 3 over 2. So this is another set of answers. Now, check out the plus or minus. That plus or minus means I have 2 answers, and that's going to be important for us later. So keep that in the back of your mind. 2 answers. All righty? So, ladies and gentlemen, our zeros are x equals 4, x equals 2/3, and x equals negative 1 plus or minus I root 3 divided by 2. So let's double check. I was supposed to have 4 answers because that's my degree. I have 4 answers down here when I'm all said and done. Does it satisfy our Descartes rule of signs? Well, let's take a look. I had 2 positive. Okay, I had 0 negative, and I had 2 imaginary. Booyah, grandma. Alrighty, so let's go to the next one. Now, the next one's going to be a couple of tips and tricks from good old Mr. N to try to make this easier. First off, we are solving, we are not graphing. Solving and graphing, different things, okay? This is solving. So this is for solving only. If we were graphing this, don't do this. Okay, the first thing I see is it's a negative x cubed. I don't like my leading coefficients negative. They just ruin the whole thing for me. So when you find a 0, technically you're supposed to make the f of x a 0. So what I'm going to do is I'm going to multiply or divide everything by a negative 1. So I get 0 is equal to x cubed minus 3x squared minus 4. That's just going to make your life a lot easier. Excuse me, plus 4. Thank you. So plus 4 is just going to make your life a lot easier. There's nothing that you did wrong. It's just going to make our life a lot easier. Easy peasy lemon squeezy. So now let's look our degree. Okay, so this is a 3. So I'm going to have 3 answers. Okay, now what I notice though is it goes 3, 2, and then I'm missing an x before I get to the no x here. So I'm going to rewrite because this is what we call a skipper. Because I'm skipping the x term. So we're going to rewrite this as x cubed minus 3x squared plus 0x plus 4. Now we're ready to do our synthetic division. So I need my list of zeros. My list of p over cubes. So the numbers that make 4 are going to be 1, 2, and 4. And the number to make 1, my leading coefficient there, is 1. So this is nice. That means our answers are plus or minus 1 over 1, plus or minus 2 over 1, and plus or minus 4 over 1, which is just 1, negative 1, 2, negative 2, 4, negative 4. Again, sports fans, you can, by all means, do Descartes' rule of signs, but to make this video go a little bit faster, because I'm already at 13 minutes, I want to go ahead and just jump straight into it. Okay, it's just going to reaffirm what we already know. I'm going to erase this so I have some room. I like everything to be connected. And if you needed to see it, just hit the old rewind button. All righty. So I'm going to go ahead and jump straight to the answers. Remember, it's guess and check. You want your remainder to be 0. So 1, negative 3, 0, and 4. 2 being one of our answers. We'll get to class and you'll talk about your calculator trick to help you. So 2 times 1 is going to give me 2. When I add straight down, I get negative 1. 2 times negative 1 is going to be a negative 2. So that's going to give me a negative 2. That's a negative 4. Add down, I get 0. No remainder. Perfect. This was an x cubed right here, meaning this is going to be x squared minus x minus 2. Now, at this point, ladies and gentlemen, you can do synthetic division if you want to again. But why not factor? It seems like a little bit easier to me. So what are the 2 numbers that multiply to negative 2 and add to negative 1? Negative 2, positive 1. So we're going to get x minus 2, x plus 1 is equal to 0. So I get x minus 2 is equal to 0, x plus 1 is equal to 0. So x is 2, x is negative 1, and we have 1, 2, 3 answers, all those highlighted pink answers. Now, notice we have 3 answers, but 2 is a multiplicity of 2. It's a double root, okay? So the way I would write this is just a negative 1, and then 2, okay? I wouldn't write the repeated answer, okay? You don't have to. If you want to, great. Don't have to. Alrighty. So let's go backwards now, and that's what this next section is going to be all about. Saying, hey, dudes and dudettes, how do we do this when we have already given our roots? So I'm going to just box this because it makes it look a little bit easier. So in example 4, I have the roots of 2 and 3. So those are my zeros. So that's when all is said and done, I got x equals 2 and x equals a negative 3. Well, if I want to know what my polynomial is with the least degree, that being the key word, because we could have as many, we could go on forever with the number of multiplicity roots we can have, but this is the smallest one, so that's why we just have the 2. So I'm just going to leave it as, alrighty, let's leave it as just these 2 roots. So what I would have had was x minus 2 is equal to 0, and x plus 3 is equal to 0. And then I would have said, well, that came from the 2 parentheses right next to each other equaling 0. Notice I said we were going backwards. We're literally going backwards. And now you're going to do double distributive or FOIL. And we'll get x squared plus 3x minus 2x minus 6. Or our final answer, x squared plus x minus 6. Boom shakalaka. There we go. So that is our answer right there. Easy peasy lemon squeezy. All right, let's go to example 5. Here, I have 0, 1, and negative 2, so x equals 0, x equals 1, and x equals negative 2. How did we get those? Well, that's because x was on its own side. I'm going to leave that one right there. So this x equals 0 part, that is what basically, this came from a GCF. They had a GCF of x in common. We factored that right away. So that's why it's just going to stay 0. So I'm just going to make it x, and then x minus 1, and then x plus 2. Come on, pen. It's like, it's a long video. I'm done working. Come on. Don't fail me now. All right. Now, this is what you don't want to do. Boom, boom, with that x. Pick 2 at a time. So if it was me, I would do these 2 first. Do these 2 first. I'm going to pause and fix my pen. Just give me one moment. Alrighty, thank you for allowing me to pause and fix my pen. Hopefully it's fixed. I'm going to do double distributed with those first, and then I'm just going to do the x at the end. So this would be x squared plus 2x minus 1, x minus 2. So x squared plus 1x minus 2. And then I will take this x and distribute it down. And I'm going to get x cubed plus x squared minus 2x. And that is our answer. Boom shakalaka. Alrighty. So, ladies and gentlemen, remember how we talked about our imaginary numbers coming in pairs? How do we get imaginary numbers? Okay, imaginary numbers come from the idea that I'm trying to take the square root of a negative. Well, when does that happen in our roots? That happens when we're doing the quadratic formula. In the quadratic formula, ladies and gentlemen, that is always going to be negative b plus or minus. And that plus or minus stands for 2 answers. So over here, we have, hey, I have 4 as one answer, and then I got plus or minus 2i. So this is actually saying that those are 2 answers right there, 2 zeros. So same idea, x equals 4, x equals 2i, x equals negative 2i. Cool? Alrighty. So we're going to go ahead and say x minus 4, x minus 2i, and then x plus 2i. Now, if it were me, I would do this part first. Why? Because those are going to be a perfect square, a complex conjugate, if you will, and they're going to make the imaginary numbers go away. So x times x is going to be x squared. X times 2i is going to be positive 2ix. And then negative 2i is going to be minus 2ix. And then last but not least, I times I is going to be a negative 4i squared. Now, what's important? These are opposites. They're going to cancel each other out. Opposites. Positive and negative, they're gone. So I get x squared minus 4i squared. So remembering from algebra 2 that I squared is a negative 1. So this is negative 4 times negative 1, meaning that this is x squared plus 4. All right, now bring this one down and be x minus 4. And do our double distributive or FOIL, whatever you want to call it. And so I'm going to go ahead and get x cubed plus 4x minus 4x squared minus 16. Putting it in standard form. Boom, shakalaka, there's our answer. Booyah! Alrighty. Ladies and gentlemen, boys and girls, that is the basis of going backwards. Now we have 2 more problems. In these 2 problems, what we're going to do, ladies and gentlemen, is say, hey, that's all said and good, but what if my a value was something different? So when we talked about polynomials, ladies and gentlemen, boys and girls, we said that there's an ax to the n. I should say a to the sub n, x to the n. So this right here could be many different numbers and still cross at the zeros we want. And so what you're going to do is, for this next one, because they're giving you a specific, if I erase this so we can see, they're giving us a specific instance, we need to say, hey, what is my a value going to be to give me that point as well? Now, the good news is initially it doesn't change anything. It's just at the end. Okay, so we're going to hold off to that, and we're going to find our zeros just like we did first. So x equals 1, x equals 2, x equals negative 1. So x minus 1, x minus 2, x plus 1. It doesn't matter in which order you go in. I kind of want to use my commutative property. I can rearrange those because I know that that's going to be a perfect square. So I'm going to do those first. Again, the commutative property of multiplication says I can multiply these in any order. So this is going to go and give me x squared minus 1. And then x minus 2. And then I'll double distribute here. And we're going to go ahead and get x cubed minus 2x squared minus x plus 2. All right, so that is when your a is equal to 1. That's how it should look right there at the bottom. But we want to hit this specific point. So we have this parameter. So what we're going to do is we're going to say, all righty, if I have an equation, again, equation for graphing implies a y equals some a value to get me this, that when I plug in 3, I get 8. I'm going to have to time that by my function. So what we're going to do is, remember, it goes f of x is the same thing as y. So x and 3 are the same, y and 8 are the same. Let's plug those values in. So 8 is equal to a, and then 3 cubed minus 2 times 3 squared minus 3 plus 2. Now it's just solving for a. So we're going to get 8 and then equals a, and that's 27 minus 18 minus 3 plus 2. And hot diggity dog, I get a times 8. So that means my a is 1. So that's kind of a little disheartening that we did that extra work for an a of 1. But that means, ladies and gentlemen, that y is equal to a, which is 1, x 2x squared minus x plus 2. So, ladies and gentlemen, we're allowed to our last one. This is the mamma jamma. This is the mecca. This is the problem that says, dude and dudettes, I'm in trig, and I'm going to get saucy with it. So, it says, find the third degree polynomial, which means an x cubed, with the zeros of 6, 5 plus 2i, and blank. Well, wait a minute. Third degree polynomial means it's an x cubed, which means I have 3 answers. 1, 2. Where's the third one? Well, there's a blank there, because remember, if you ever have an I, that's the quadratic formula, which means there was a plus or a minus. Okay? So that means that I'm also going to have 5 minus 2i. There's the third one. Like I said, this is going to get saucy. So if you ever have imaginary solutions, so you see an I, they're going to come in pairs. If you ever see radical solutions, that means square roots. Those are going to be in pairs as well. So let's sum up what we got going on right here. X equals 6. X equals 5 plus 2i. X equals 5 minus 2i. Now, you start the same way. X minus 6. X minus parentheses 5 plus 2i. And then x minus parentheses 5 minus 2i. All right, let's do some bookkeeping here, especially with the negative right here and the negative right here. I just want to make sure that it looks okay. So x minus 6, and then 5, distributing this here. X minus 5 minus 2i, and then distribute here. X minus 5 plus 2i. Now, at this point, even us as math teachers in the math department, we will disagree on which we think is the easiest way to do this. I personally would say that doing a box for multiplication would be the easiest, okay? Because essentially you're doing triple distributive. So this times this, times this, times this, this times this, times this, then we've already been lost. So what I'm going to do is, again, just like we talked about in the previous example, do the imaginary parts first. I'm going to go ahead and make a box. Some of you have heard this to become like a G square. I call it the X box. But I'm going to take this one and put it on the side. So X negative 5 minus 2i. And this on the top. X minus 5 positive 2i. And now, ladies and gentlemen, boys and girls, we are going to multiply. And the nice thing about using the box is that as long as we fill everything in, we didn't miss anything. So x times x is x squared. Then x times a negative 5 is going to be a negative 5x. And then I have x times a positive 2i is going to be 2ix. And then we're just going to fill the box. So the next one would be x times negative 5, and that's a negative 5x. And we're just going to keep trugging along. So rather than switching colors, we'll just sort of keep multiplying here. Minus 10i, then minus 2xi, then we have plus 10i, and then minus 4i squared. Holy cannoli. Let's look for some like terms. So my x squareds, only one x squared. My 5x's, we got 2 of those. So I got an x squared minus 10x. And then if I look at my i's here, these right here are opposites, so they cancel out. That's sweet. Like I said, there'll be some canceling. These are opposites right here, so they cancel out. Sweet. So then I have a plus 25 and a minus 4i squared. Now, let's recall, as we just got done, I squared is a negative 1, so negative 4 times negative 1 is going to make that a 4. So when we're all said and done, I'm going to get x squared minus 10x plus 29. Alrighty. Now, we can't forget this little x minus 6 up there, so that's going to mosey on down. And now we're going to go ahead and just do double distributive with that. And so, boom, 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 boom. So I should get, when all is said and done, x cubed minus 16x squared plus 89x, and then minus 174. So that is our equation. But wait, there's more, because we have an a value right up here when x is 2 and y is negative 636. So we're going to go ahead and say y is equal to a, x cubed minus 16x squared plus 89x, 174. Let's plug it in. So this is going to be a 636. That's negative, I believe, right? Yep, there we go. Is equal to a, and then 2 cubed, 16 times 2 squared, 89 times 2, minus 174. So inside those lovely parentheses, I'm going to get 8 minus 64 plus 178 minus 174, which is going to be 8. And then we're going to have a negative 52 and a negative 636. So, like I said, gnarly amongst gnarly. Normally, when you get a problem like this, you probably think that you did something wrong, but you did everything right. And we still got to reduce this by dividing by 4. And we get 13 over 159. So that would be your a value. So y is equal to 13 over 159. And then we have to distribute that to all my lovely little pieces. So when we're all said and done, woo, Nelly! 13 over 159 x cubed right here, and then times the 16. And I'm going to go ahead and use my calculator here off to the side. I'm not going to lie, I hit the pause button. I'm like, ain't got time for this. That's why we said get a calculator. Get a TI-84, because you need it for this sauciness. And then this is 1157 over 159x. Forgot my x right there. And then minus 754 over 53. Woo, Nelly! Ladies and gents, it's been an absolute pleasure going to the field of battle with you on this math problem. And we'll catch you on the flip side. Take care.